Hello, Algebra 2 students. Welcome back. We're going to talk about polynomials during Unit 6 here. And so this video goes with Assignment 1, which is in the Part 1 section. There are 5 assignments you want to complete in here before taking your quiz. And we're going to talk about the basics of polynomials. So the first thing we want to talk about are all the different parts of a polynomial. So let's, for example, take an equation or an expression like negative 2x squared plus 4x minus 6. Now you guys are familiar with this. Excuse me. This is a quadratic expression. It's also known as a polynomial. And so there are 3 different words that we use when we talk about polynomials. One is the terms. So a term is just an variable or number which is separated by addition and subtraction. So in our case here, each of these pieces or parts, so think of them as like parts of the polynomial, we have negative 2x squared, and then in between there we have a plus sign. So that plus is separating negative 2x squared from the next term. 4x is going to be the next term that we have. Another minus sign, so that separates 4x from the 6, and 6 is our last term. So this particular polynomial has 1, 2, 3 different terms. All right. The degree of this polynomial is the highest exponent that we see on each of the terms. If there is more than one variable, which we'll look at in a few minutes, with one of your terms, then you want to add the exponents together. So when I look up above, negative 2x squared, we have a power of 2. So this little component here is degree 2, if we just look at that. If you have 4x, well, there's technically an imaginary power of 1 there. So that piece is degree 1. And if there's a 6, then there's like an x to the 0th power there because it doesn't really show up. And if you remember, x to the 0th power just equals 1. So that x to the 0th power makes just a constant have a degree of 0 because there is no power. Now, when I look across here, we have a degree of 2. Degree of 1 and a degree of 0. So the highest degree that we have is a 2, meaning this entire polynomial is a degree 2. So let's add that. And then the last terminology piece is coefficient. A coefficient is just the number in front of a variable. All right. In polynomials, we like to have what we call standard form, and that's when you have your terms going from the highest degree down to the lowest degree. So negative 2x squared plus 4x minus 6. This one is in standard form, and the coefficients are negative 2, 4, and negative 6, so you're taking the sign with it. That's a good note to write down. You take the sign with it. We also have something called a lead coefficient, which would be the number in front of your first term, and that term must be the term of the highest power. So this is your leading coefficient, which will become very helpful to you when you get into pre-calculus or beyond. Now, each of the polynomials that we're going to look at has a specific name, and you name them by the number of terms that you see. So, the first word that we have here is monomial. Mono, that prefix, if you remember, that means the number 1. So a monomial is a polynomial of only one term. An example of that might be just x squared, or 5, or 6xy. So there shouldn't be any addition or subtraction in there, it's just one term. Binomial, that prefix means 2. So this is a polynomial with 2 terms. So it might be something like x squared plus 5, or 6xy minus 2. Anything like that would be a binomial because there are 2 separate components. Trinomial, just like a tricycle, means 3. So this is a polynomial with 3 terms. So 6x squared minus 5x plus 1, that would be a trinomial. And then the prefix poly, this just means many. So a polynomial is any of those polynomials where you have more than 3 terms. So 4 terms or more is just considered a polynomial. And technically, trinomial, binomial, and monomials are also polynomials. They just have more specific names because those are the kind that come up the most often for us. And so 4 plus terms maybe looks like 6x cubed plus 5x squared minus 9x plus 10. All right, so something where you have 4 individual terms. All right. So to determine the degree of polynomials, we said the degree was the highest power that we see in our terms. So what I do is go through each of my terms and determine the degree of each. The highest one is the degree of the entire polynomial. So let's start with this first example here. 4x squared, negative 4x squared plus 3x minus 5x cubed. So looking at the first term, negative 4x squared, the degree is the power, so that has a degree of 2. The next one, 3x, remember we talked about there's like an imaginary 1 there, so this is a degree 1. And negative 5x cubed is a degree 3. So this entire polynomial is a degree 3 because that's the highest one. It's a little bit trickier when you have more than one variable showing up. So if I see something like 5xy and 6x squared y, you want to add the powers on each. So 5xy, x is to the first power and y is to the first power. 1 plus 1 makes it 2, so that is a degree 2. X squared y, again there's a power of 1 on y, so x squared and y to the first makes it a degree 3. So this entire polynomial is a degree 3. You don't often see the 2 variables together because most of the time those are not functions, and we like to live in the world of functions. So usually you'll only have 1 variable to figure out, but that can happen. And then the last example here, if I just give you the number 4, well there's no x, there's no variable even on that, but x, or any variable to the 0th power, is always equal to 1. And so that's what's really happening here. It's 4 times x to the 0th power, which we don't write usually, but that makes this whole thing a degree 0. Okay, the last thing we're going to talk about for today is adding and subtracting polynomials, which is on the back side of assignment 1. So when you're adding and subtracting polynomials, you're essentially combining like terms, which I know you're already good at. However, we'll just refresh our memories. So when you combine like terms, you want to make sure you're combining the same variables, and those variables have to be raised to the same power. So an x cubed and an x squared cannot be added together. But an x squared and an x squared certainly can. You can multiply any type of powers you want, but for adding and subtracting, they have to be the same variable with the same power. All right? Oops, I missed the word same in there. So let's look at an example. This is number 14 from your worksheet. So we have 9r cubed plus 5r squared plus 11r plus negative 2r cubed plus 9r minus 8r squared. So in order for us to add these two polynomials together, right now we have two different trinomials, 1, 2, 3, 1, 2, 3. We need to go through and combine like terms, and I always want to write it from the highest power down to the lowest power. So starting off here, I see 9r cubed, that's the highest power over here. And in the other polynomial, we have a negative 2r cubed. Well, 9r cubed minus 2r cubed, 9 minus 2 is going to give us 7, so we're just adding the coefficients, and the variable stays the same. It's like saying I have 9 oranges and I want to take away 2 oranges. Well, you have 7 oranges. The orange didn't change, just the amount that you have. So the r cubed stays the same here, but the number in front, the coefficient, changes. Okay, and when I'm doing this, I like to cross off the ones that I've combined as I go so that I don't get confused about what I still have left. The next highest power I see is negative 5r squared. And in the right polynomial, I have a negative 8r squared. So be sure to take the sign in front of your term with it. So it's 5 minus 8, which gives me negative 3. And again, the r squared is not changing. And then lastly, 11r and 9r. Well, 11 plus 9 is going to give me 20. R stays the same. Simple as that. All right, for the last part of this, we're going to subtract two polynomials. It's really the same concept as adding, but instead of adding all your like terms, we're taking the first set of terms and we're subtracting from it each of the second set. So what I'm actually going to do here is to still think about it as addition. I want to take this negative sign, which is really like a negative 1, and distribute that to all my terms. All right. Now if you're really sharp, then mentally you can just think about subtracting each of them. But oftentimes small mistakes occur, so to try and alleviate those small errors, I want to just distribute through that subtraction. So that's the only addition, the only difference between adding and subtracting polynomials. So we're starting with, and I'm just going to rewrite my problem, 8n minus 3n to the 4th plus 10n squared. That one stays exactly the same. But then over here I need to subtract the 3n squared. So it becomes minus 3n squared. And then negative 1 times negative 11, times positive 11, is negative 11n to the 4th. So you're subtracting 11n to the 4th. And then negative 1 times negative 7 makes that a positive 7 because we're subtracting a negative 7. So now you can look through and just combine up any like terms. We want to start, like I said before, with the highest power. So negative 3n to the 4th, negative 11n to the 4th, negative 3 minus 11 is going to give me a negative 14n to the 4th power. Cross them off as I go. The next highest power is the squared, so 10 minus 3 is going to give me a positive 7n squared. And 8n, well, there's no other term that has an n on it, so that term, if there's nothing to combine it with, I'm just going to bring it down. And same idea with the 7, there's no other constant, so we're just going to bring that down as well. So your final answer here is negative 14n to the 4th plus 7n squared plus 8n plus 7. 4 terms, so it's just a polynomial. And because the highest power is a 4, it's also a degree score. So go ahead and try your worksheet assignment 1, and when you finish that, the answer key will be open for you. So check your answers, make corrections. In order to receive full credit for these assignments, you also want to correct any mistakes that you have and submit those corrections as well. You can do it right on the same paper, just circle or highlight or something the ones that you've actually corrected.